Today's problem is nearly sorted, difficulty medium, accuracy is very high. Maybe because if you read through the problem description, they provide a lot of hints. Given an array where each element is at most k positions away from its correct position in the sorted order, your task is to restore the sorted order of the array by rearranging the elements in place. Okay. Yeah. Don't use any sort method. That would make it too easy. So, as an example, 2, 3, 1, 4, k equals 2. What is that? Yeah, go ahead. 2, 3, 1. Okay, so nothing is more than 2 positions away from where it should be. So the 1, for example, is two positions away from where it should be. 2 and 3 are 1 position away. 4 is already in position. And so, yeah, we can arrive at something like this. This is already sorted. Array size is somewhere between 1 and 10 to the 6th. 1 million. So that's a lot. You know, we need to be mindful of that. K is between 0 and the size of the array. And the elements in the array are between 1 and 1,000,000. Okay? Expected complexities. N log k, right? Auxiliary space, O of k. That's a good hint. Topic tags. Sorting. Yeah, but we're not really allowed to do a sort. Priority queue will do sorting. And the fact that they mentioned priority queue and O of k suggests that a priority queue of length k might be helpful here. All right, let me move that over and see if we can see everything. Yes, okay. Something that I didn't pay attention to the first time is that k can be 0. So if k can be 0, we're still going to make a pass through the array derivation. Okay, so let's add something here, and that is if k equals 0, just return. Okay, edge case. All right. N will be the length of the array. I will be 0. We will create a priority queue, and we will put the first k elements from the array into the heap, right? Yes. So let's look at this. Actually, we could probably trace through this. Let me get a pen. All right, I'm going to copy the array here. The array is 2, 3, 1, and 4. All right, so now we need a heap. I guess I can put the heap right here. Anything else we need to keep track of? No, I don't think so. All right, so I is, I is 0. And from I is going to go from 0, just 0 to 1, and we're going to put the first 2 elements of the array in the heap. That is 2 and 3, and so they would go in the heap like this. It's descending order, right? So 2 and 3. I would go from 0 to 1. Actually, I would go from 0 to 1. Actually, it would go to 2, and that would end the loop. So I is now 2, right? So for I is going to go from 2, well, actually from 2 to 3. We will offer array at 2, right? So array at 2 is 1. So that would go in the heap right here. And now we will take array at I minus, let me write I down here. I is 2. I minus k, 2 minus 2 is 0, equals, take the first element off the heap. It's a 1, right? So we'll take it off. Did I get the right thing there? I think so. Okay, it's coming off. And array at 0 is going to be 1. All right, increment I. I is now 3. Heap, offer, array at 3. All right, so to put that in the heap, it would go here. Now, array at I minus k, 3 minus 2. Array at 1 equals, and we're going to take the first element off the heap. It's a 2. Okay? So 2 goes here, this goes here, and this is going to be a 2. All right? Now, I is going to go to 4. That's too big. So we are done with that for loop. I is now going to equal n minus k. N is, excuse me, length of the array, which is 4, and k, which is 2. So I is going to equal 2. I is 2. While the heap is not empty, array at I will equal first element of the heap. Okay, so take the first element of the heap. I is index 2. That is going to go here. We have an increment here on I, so I is now going to be 3. We're going to take the element from the heap, which is 4, and put it in the same thing, 1, 2, 3, 4. So it is sorted now. So the idea here with a priority queue of length k, starting with the first 3 elements in the array. Okay, so the heap will sort those, and we can take the first element from the heap, we can take the element from the top of the heap and put it at the front of the array, and then put the next element in the array in the heap. And so we've got kind of a sliding window across the length of the array, maintaining a priority queue of length k, and the minimum number, since we're guaranteed that nothing is going to be more than k positions out of where it should be. If we have a priority queue of length k and we just slide it across the length of the array, we're going to be able to just take the top element from the heap in each iteration and add it in order to the array, and that should sort it. Let's go ahead and get rid of the notations. Let me do a sanity check on the oh whoa. Yeah, why can't I do that? Right here. Yeah, really, this, okay, here we go. That should auto hide. All right, well that worked. And then this, okay, we'll submit it. All right. One day. Oh, that's bad. I thought I did it yesterday as well. Well, okay. So that is so that's the nearly sorted problem. I mean, they're giving you enough hints here that the problem sort of solves itself. When it says, you know, use a priority queue, and by the way, your auxiliary space is going to be O of K, then yeah, priority queue of length K solves the problem. All right, so please give the video a like. You can subscribe to the channel as well, and we'll see you next time.